Welcome to It's a Controls Problem, where we do precision guesswork based upon unreliable data given to us by those of questionable knowledge. I'm your host, Charles Johnson.
Well, before we sign off here, I really wanted to give a shout out to a particular person who listens in on our show. Thomas Trang is a really big proponent for us, and he definitely has a good presence on LinkedIn. And so, he's continuously, posting about us, summarizing our podcast for people and writing articles about it and just trying to get as much presence out there for us as possible, all without anything in return. So Thomas, thank you very much for doing that. I really do appreciate that.
Thanks for being our number one fan, Thomas.
Well, welcome everyone to another episode of It's a Controls Problem. I'm your host, Charles Johnson, and I'm here with none other Matthew Vanberg. Matthew, hello.
Hello. How are you?
I am just wonderful. And we actually have a very special guest here today. Is it Nick or Nicholas?
I go by Nick. Hi,
Nick?
buddy.
Alrighty. So we have Nick Gayeski here, and he is the co-founder of Clockworks Analytics. So Nick, welcome to the show.
Glad to be here. Looking forward to the conversation.
Absolutely. So we're just going to kind of dive right on into it. So Nick, from what I know, you have a background in building technology from MIT, which is very impressive. And it's also a very different starting line, than the typical kind of like van and ladder path industry that a lot of people take into it. So, looking back at your time in academia, what was the specific moment or experiment where you realized that the way that we manage heating and air in large buildings was just fundamentally broken?
Yep. Well, first I'll say in our industry, I'm very familiar with the term piled higher and deeper. So for those who don't know, PhDs tend to get a reputation of, it's just BS, forgive my language, but piled higher and deeper. And so it makes me very cognizant that people in our industry who've taken the path, starting as a technician, building experience, doing lots of projects and jobs, that's tremendous knowledge and to be highly valued. But yeah, I started, I don't know if I'd say started, but I got a PhD in building technology at MIT, largely because I wanted to focus my time and attention on building energy efficiency broadly. And that quickly became a combination of modeling. So I actually worked as an energy modeler for a little while on construction projects using tools like eQuest and Energy Plus, but then also did some work for a VRF manufacturer doing model predictive control for VRF systems. And my PhD work was all about model predictive control of cooling systems, chillers and vapor compression systems, but pre-cooling thermal storage. So how do you operate under low lift conditions a lot of time and reduce energy and reduce cost and avoid peaks and operate overnight and all that good stuff. So I think all of that goes back to wanting to do something impactful and meaningful in the built environment to address energy problems and climate problems.
You're definitely, you seem to be approaching it from the perspective of thermodynamics. So I guess that physics first mindset led you to co-founding Clockworks.
Yeah, I would say that plus this just feeling like data driven. It was the buildings industry has a lot of data out there in terms of sensors and actuators. Why aren't we doing more with it? Or why weren't we doing more with it at the time? And this goes back, almost 2 decades now for me. So it's sort of bringing the physics, engineering, thermodynamic mindset, and then the data driven mindset to how we understand how buildings are functioning and then what we do about it. Yeah.
So here's a question I like to kind of ask people, especially among a variety of different ways they get into the industry. So what was the biggest culture shock that you experienced early on in your career when moving from the precision of a research environment into, the environment of the reality of a mechanical room?
Well, my research environment was maybe different than what people think of as a research environment. I was very much an experimentalist. So when I did my model predictive control research, I was literally buying split system air conditioners, modifying them to serve a brazed plate heat exchanger and the air side evaporator, and then programming a legacy Siemens Insight system for a test chamber to implement a model predictive control sequence. So for me, I kind of was already in this world of like making it work and working with a variety of different programming languages and technologies and sensors and legacy systems and new systems. So the culture shock for me wasn't very big because a lot of my research was very like hands-on compared to what you might normally see. And also, I was working in parallel. So we actually, so some of my energy modeling work and then my work with the VRF research was while I was doing PhD work on the side. And then we started Clockworks 3 years before I finished part-time, known as KGS Buildings at that time. And so the transition, let's just say, was very, very gradual and organic and kind of happened continuously throughout the work.
Yeah, that's actually really cool. Like, and especially when you mention Insight, for me, always my first Insight experience, or my first experience with Insight was a hydrogen facility in South Carolina, and they had a reliable control system in there. They had Honeywell and they had Siemens. And they're like, "Hey, do you know Siemens?" I was like, "I'm like sort of. I'm like, I know the programming side, but what do you need?" "Well, we need to calibrate some of these sensors." I was like, "Okay, well that can't be too hard." And then I look and I see that you have the slope and intercept. I was like, "Oh, we're really calibrating this." Okay, all right. So yeah, no, I actually think that's really awesome that that you had that kind of experience. So the transition really wasn't bad at all for you because you already kind of had that. I really like that unique approach to it.
You'll appreciate this story then. It's one that still cracks me up, which is the lab that I worked in was actually built in the 90s to do computational fluid dynamics research. And at the time, it was it was an Insight system running on Windows 95. And it had not been used when I went to resuscitate it and use it for my work. And so I had to buy a copy of Windows 95 and then install that and then cold start the cabinet that was left on the wall from way back then. And so it was like mid 2000s, but running Windows 95, or mid to late 2000s running Windows 95 and an old Siemens system. So I was having to jump into the PPCL and resuscitate it. It was quite a thing.
I actually still have a VM with Windows 98 on it. There was a program called Reverse AutoCAD, and it was designed to reverse engineer. So the old Network 8000 stuff, it was actually designed to reverse engineer a GCM backup. So if you had a backup from a GCM, it would actually build AutoCAD drawings of how it was actually programmed so you could see it visually instead of trying to do everything through DOS-based block programming.
That's really cool. Ahead of its time.
Yeah. No. So like I was like, oh yeah, I still have a laptop somewhere with Windows XP for Train with Rover as well. I've got some relics sitting in my house. Mm-hmm. So was there a specific building or project early on where you came to realization that data could see things that a technician's eye simply couldn't?
Yeah, I suppose that moment really came down to one of the first buildings we deployed. It was a higher ed lab building with with 10 large air handlers between 50 and 100,000 CFM. 8 of them were 100% outdoor air, and they were serving, lab spaces, let's just say. And I think there was maybe 1,200 VAV boxes in that building too. The story there is like the technicians, HVAC and BAS, who worked in that building knew there were a number of problems, but just the volume of equipment made it hard to find them all and find the root causes and address them all. So having our software collect all that data, apply standard metadata to it, run consistent analytics across all of it, and then identify root causes, just really accelerated their ability to fix a lot of reheat valves that had failed due to scoring, fix a bunch of chilled water and hot water valves that were leaking by. They did have a couple of economizers in that building, so there were a couple economizer issues. So sort of like the volume combined with the complexity of that building just made it intractable for even the smart HVAC and BAS techs who were in there to find, diagnose, prioritize, and fix everything. It made it pretty clear that we had a role to play in helping. I actually have, I don't think anyone could see this, but I have one of those valves on my desk. So it's a paperweight now.
Nice.
Yeah.
So how did the transition from researcher to entrepreneur change your view on what solving a building actually meant?
I suppose, as I worked on model predictive control and optimization type work, I got excited about kind of like the innovative mathematical and technical boundary pushing areas, like better ways to do optimization or more creative ways to drive efficiency as low as you could possibly go or costs as low as you could possibly go. Transitioning to entrepreneurship and working directly with clients and building owners and facilities teams, I started getting a lot more excited about scale. Anything that addressed problems at scale or helped with, the current state, but in a big way, in a highly scalable way, that is a lot more interesting because you can do a lot of interesting and creative things that are intellectually fun at a small scale, but to make a big impact, you have to figure out how to do sometimes smaller, less intellectually creative things, but the creativity comes in how you do that massively at scale.
Yeah, I think that's a very good point. There are people out there that just try to start really big. And when you start really big, there are so many things that you can't consider or take into consideration that, while you may have a good portion ready, the rest of it around it is not very good. And so, I always try to preach that to people, like start small first, get that sound. And once that is sound, you can then move it away. You can place it into a lot of areas. I think, intelligent design comes with, cogs and once you intertwine them all, once you get each individual cog, set up just right, then you can figure out where you put them in the pieces, literally just to get them all in motion. And at that point, it's just a work of art.
Yeah, that does resonate with me. I mean, we certainly started small with, with live buildings and real customers and building and handling different cases and variations. I think part of what made it the magic of scaling was as you encounter those different scenarios is building it into an approach that continues to scale, that builds on itself. Rather than a lot of one-offs. And, I think in our industry in particular, building, controls, energy, people get stuck a lot at sort of a small to mid-level scale. So how you go from those initial experiences and sort of refining it at a small scale to how do you do it at a big scale is as much an art as it is a science, but sort of the critical part of breaking out.
Yeah, I mean, so this kind of leads me to my next question, which I think kind of you already answered, but I think that I think a little clarification could go with this. So, like, on this show, we talk a lot about this, but from your perspective, why is it that we can have the most advanced sensors in the world, yet we struggle with like the most basic sequence of operations compliance?
Yeah, I mean, I think that there are so many different ways to answer that question. I'm not even sure where to start. But I think a lot of people don't fully appreciate the diversity and complexity of the way buildings are operated and managed. I mean, you can have the most state-of-the-art building with the most state-of-the-art sensors and devices and automation and even agentic AI built into it. And a valve is still going to fail. And, a damper actuator is still going to wear out. Mm-hmm. And somebody's going to log into that system and look at something and accidentally make a change that affects everything else. And when it's that automated and that intelligent, like that one change could affect many different things. So they actually get more complex, and in some ways more brittle. So I guess, this idea that we can have really sophisticated and advanced technology, but still get encumbered and held back by simple things is, I don't know, the complexity of marrying technology with people and the physical world. And I don't know. I'll go back to thermodynamics. I like to joke with people that, well, entropy is a thermodynamic law, and it's never going away. So my answer to you is entropy.
As soon as you mentioned thermodynamics, I'm like, he's going to say entropy. I know he's going to do that. I think that, for me, I think probably the way that, from my perspective, I think it's people don't understand the end goal, in a lot, right? So like, people want a lot of things, but they don't know exactly what to do with it, like analytics, right? So, from a Niagara perspective, I do get questions. Yeah, well, can you do Niagara analytics? I'm like, well, yeah, we can do it and I can show you, but what do you want to do with that information? Like, you have to build it all. That's the, well, at least from Niagara, you have to build it all, but like, I think that some people just don't know what to do with it. It's like, well, you got it, but where did you see yourself putting it there? And then you're right, people making changes that all of a sudden affect everything else. Like I tell people, you try to make something idiot proof and the universe creates a better idiot. And you're right, dampers wear, valves fail, a lot of that is there, but even then, that's still what, part of, you can use some analytics there as well to determine, failed actuators and sensors and stuff like that. Like, I remember doing analytics before analytics was actually a thing. Like, I would, like for fan status, I would never use a current switch. I would always use a current transducer. And so at that point, I would look at the amp draw. So obviously if a filter was clogged, well, the fan's going to work less. If we have a belt that's broken, the fan's going to work less. Right. So then, and even then over time, once you take like the 5, 10, 5, 15 and 30 minute histories of that amp draw, and then, put that in over time, you could actually take someone, hey, look, your fan performance over the course of these years is now no longer optimal anymore. Now it's time that's probably to replace your equipment. So I think without having that direction, I think you're right. People can put all this in here, but it still doesn't mean it's a fully functioning system.
Yeah. Yeah. In terms of what Clockworks does, making sense of data from buildings in a scalable way that will inform actually resolving and taking action, or in due course with the proper cybersecurity considerations, automate various workflows. So back to the BMS or automatically to the right vendor, and so on. That's kind of where the rubber meets the road in addressing those problems that come up, that complexity of the intersection between technology and people and operations, but making sense of the data to do it better and do it more automated and do it with scarce resources and scarce people, few people. That's the key to what we're doing. And to your point on, like, there are plenty of solutions out there where you can build what you want if you know what you want and you know how to build it, but that's really hard. We have really come at it from the angle of what is the end client, the building owner or the service provider, really trying to accomplish and make sure end to end we can help them do that. They don't have to figure out how to create it and build it out of our product. Our product just helps them do that out of the box, which is usually like reduce energy, eliminate unnecessary maintenance activities, escalate maintenance that is a bigger priority, avoid downtime, improve reliability, same thing, manage compliance better. There's any number of things that relate to managing assets more proactively with analytics, but it's that focus on what it is they're trying to achieve, not kind of leaving this gap where they have to figure out how to get there. That has been important for our success.
Yeah, I couldn't agree more. I really do like your product as a whole. As a matter of fact, I actually know Tim Kramer, known him for a long time. Very good guy. So no, I think your product's amazing. I think what you're doing, at large is there just to help, help buildings be smarter and helping, the people make better informed decisions based upon the outcomes, of the system. So when you look at the industry today, what is the most frustrating standard practice that you think is holding us back from, let's say reaching like carbon neutrality?
Hey, Controls fans, Matthew here. Charles and I have recently formed the Logic Link Collective with our friends over at Stacks and Jewels in order to get the word out about the current knowledge gap and how their team is working to solve it. Good controls techs are hard to find, but Stacks and Jewels is building them from the ground up. 14 weeks of hands-on training on real equipment results in graduates who actually understand the ecosystem of a building. They are doing the heavy lifting, but they need the industry to meet them halfway. You can contribute financially to support their mission, or you can give your time as a mentor or technical advisor. If you're hiring, stop looking for unicorns and start looking at Stacks and Jewels graduates. Everything you need to get in touch is in the show notes. Let's support the people who are actually solving our industry's biggest problems. As always, thanks for listening.
Well, carbon neutrality is an interesting angle. I'm going to back up, though, to just go back to the most frustrating practice. And I don't know if this is the most frustrating or the most recent and frequent that I'm thinking about and feeling. So whatever it is, I'll go with this, which is, I think planned preventative maintenance is flawed, and it's really time to rethink standard maintenance practice. You hear this drumbeat of, we don't have enough people, either we don't have the budget to hire enough people, we can't hire the right people, we can't retain the right people, we have this massive deferred maintenance backlog, we can't grow our service business, and yet the conventional way of doing things is these planned preventative maintenance tasks where there are monthly, quarterly, and annual things that skilled maintenance people are supposed to go do, which may have no real impact on the health of the asset, the quality of the operations, the energy consumption, the energy cost, the carbon emissions. It may just be sort of, this strictly defined set of work that they're supposed to do. I think that with connected assets and analytics on those assets, that whole thing needs to change so that we are optimizing what is very valuable human capability on tasks and work that actually matter to the health of that asset, to the reliability, to energy efficiency, to cost.
Preach. Yeah, that's a really good insight. I think that's a lot of the issue right now in facility management as well. So here's another one. How do we fix that execution gap where software identifies a problem, but the work order never actually gets closed?
Well, do you mean the work order never gets closed, or it gets closed, but it's not actually fixed?
Ooh, that's a good question. Let's say never gets fixed.
Yeah. So I think that's a problem that is solvable with a connected asset strategy, where you've got data flow, you've got diagnostics running. We can already see today, we do work order integrations. So, you'll see a diagnostic finding in Clockworks, you escalate that into a piece of work to do, which is synced up to the work order system. The trades or whoever is working it, they do their work and they close out the work order. We can see on our side whether the problem that we had identified has gone away or not. So, what we're moving towards is automated validation as to whether the work they said they did, whether or not they did it, also whether or not it fixed the problem, or maybe it uncovered a different problem. They fixed what they thought it was, but there's still a different issue that they then have to go back and fix. So I think this closed loop process of monitoring the asset itself and determining what the problem is, and then relating that back to the work that was done and whether the what they said they did fix the issue, that's where it needs to go. So I forget exactly what your question was, but that's the solution.
No, I think you answered it, because you're right. There's also been a cycle where it's just been reactionary, right? So they only fix things when they break or when someone complains, that they're hot. So I think what you're doing is moving that needle towards a condition-based maintenance without, making the team feel like the software is actually tattling on them, right? So it's there hey, cool. By the way, you thought you did this, but this is still the problem. And so it's okay, thank you.
Right. I think the point there, kind of implicit in your comments, this idea of tattling, right? That's a negative spiral for everybody, right? The people who are trying to do good work, they feel like they're being called out. The people who are just trying to manage a building well, they're not getting what they need. So this dynamic of it being tattling needs to, no one needs that. It should be more about a tool everyone can use to learn, to validate, to improve their effectiveness, improve their efficiency. And I think this goes throughout the facility's sort of stakeholder chain, where, a lot of times there are technicians that they're doing the best they can, but maybe they haven't been trained up in certain areas, or they've been told how to fix a problem, but the root cause was something different. So they just didn't know. So having that feedback of, did it actually fix what I thought it did, I think is good for everybody, as long as the dynamics of the end customer, the vendors, the service providers are more transparent and positive in terms of what everyone's trying to accomplish.
Yeah, and you're right about the tattling being, absolutely that negative term. So wording is definitely important for sure. And no one wants to feel like that, that they miss something, but we all do. Because, especially from when we look at it from the perspective of, okay, we have X, Y, Z that could be the root causes. And so you choose one, and then, all right, it may seem to fix itself. And then all of a sudden happens again. Okay, well, we've rolled out that first one. Now let's go with the second one. Okay, seems to have done something now. And then it's like, all right, well, I guess we're to go with option C. And sometimes, it feels like, when you're flipping a coin there, like you may have a gut idea, but then it's like, all right, I should probably go through this checklist first. And then all of a sudden it's like, oh man, I wish I would have just gone my gut first. But you never know, whether or not that actually is the issue to start until you go through, that proper, that proper execution task, as I like to call it, to make sure that you've got those basics covered.
Yep.
So, you mentioned AI, and people know how I feel about it. But what is the biggest myth about artificial intelligence in building that you constantly have to debunk?
I don't know that there's one myth that we constantly have to debunk, other than this idea that somehow LLMs are the panacea. Like all of a sudden everyone's aware of AI because large language models advanced, and so it's on everyone's mind. And because of that, large language models are just going to solve everything. I think, that's a well-known myth, but still a myth that you see out there. I mean, to their credit, tools like Claude are mind-blowing right now. And I think, things really changed kind of end of 25, early 26 in terms of what its capabilities are, and particularly with model context protocol and connectors and getting, synthesizing information and then doing things with it. But a lot of that is really, language-based and contextual. If you don't have the right metadata and data and engineering calculations, where engineering is what matters, then the insight, quote unquote, that the LLM generates could be deeply flawed. So I more than ever think that structured data, structured metadata, and a role for engineering calculations, like through the expert systems that we use, are going to be critically important in enabling reliable, traceable, defensible AI workflows, where you have, agents that are using tools like LLMs and generative AI, but that are interacting with knowledge bases that are based on, structured data, metadata, and engineering calcs from which to automate and reason, quote unquote, other AI driven insights. So, there's a lot more than LLMs in the AI world. And just because AI is advancing so quickly, it doesn't mean there isn't a role for things like ontologies, expert systems, or frankly, just math and engineering.
Yeah, you're right in that. My frustration with AI recently has just been the vibe coding thing, where I get a lot of people that ask me, "Hey, I put this into Claude, or I call it Chat Jippity." But that they're like, "Hey, can you help fix this?" I'm like, well, first off, you shouldn't be using this unless you know the language to begin with. And knowing what to feed it is also equally as important, because it just doesn't know. Like, obviously, people have been, with ChatGPT, people are afraid that, that when you feed information, their data is public, which is why I like Claude, because Claude, you can make it private. So like you have your own little Claude server, as long as it's not deleting databases left and right. Why people are giving Claude access to databases and then it just goes and deleted is beyond me. But it's feeding it the right tools to give you the best solution that you can, because otherwise, if you're feeding it flawed data, it still could give you flawed data. And because you don't know any better, you just assume that, oh, well, this is what it thought about. And so, it's correct there. So, I think that, for me, it's just always, it's always a gentle approach with it to start. Do I think it's going to be the end all be all saviors of everything? No. But I think that over time, as you mentioned, that, it will get better as people learn how to interact, with those systems. I think that's really the big thing, is people want to dive in head first without really having the proper background to kind of feed it. And so then it's like, now you're in this cycle where you're wasting, all my credits are done for the day. Well, I've already used AI. I'm done with work. I guess I'll come back at 12 p.m. tomorrow and get started again. You know,
I love dispatch though, because then you can work overnight.
Yes, very, very true. You know, yes, you are not wrong there. And you're right. Like MCPs are becoming extremely popular. Niagara 5 has an MCP server or a service that you can put in there. And I actually saw it work at Niagara Summit. It was actually pretty nice to see. So yeah, like seeing some of that stuff is really good. But I can't imagine the amount of work that people put in there to get the outcomes that they had. And and actually this leads me into my following thing now, is like you just mentioned ontology. So you're obviously a vocal proponent for organized data. And so how do you perceive, I already know this answer, but how do you perceive the importance of a standardized ontology like Haystack or Brick to the future of this industry? And why is it so bloody hard for everyone to finally speak that same language?
Yeah, I think that for reasons you've already alluded to, in order for AI to work well, to give you reliable, accurate outputs, and to kind of assist in tasks and create more value for you, it almost presumes a way to interpret unstructured data in a structured way. And so, I think of like labeling images, all the work that has gone in over the years to labeling images, just so that AI can get better at identifying things in images. Well, in the buildings industry, unfortunately, we have a lot of unstructured data about devices and points and control sequences that mean that it's really hard to train AI to understand them. Yeah, you could feed in all of that unstructured data and see what it produces, but is that going to be reliable, accurate, consistent? Can you make judgments off that? It's going to be really risky. So, if anything, one of the most valuable ways it can assist near term is helping create structure from unstructured data based on smaller training data sets that have been structured. And then as the structured data set grows, we can do even more with that. So an ontology that defines that structure, and in our case, we've been mapping to a standard ontology for years and years and years, which means we have a training data set so that when we encounter unstructured data, we can make it structured and do more things with it in that ontology. So the ontology has that role to play. I mean, I've also, at times just been kind of in this morass of like, well, language is its own. The English language is an ontology, and now English is what LLMs know. And cat and dog on labeled images is just, the ontology of English and the way that AI is understanding those images. Well, it's not so easy in the building, in a specific domain, any specific domain, buildings and controls included. I've encountered points in the UK where the point named flow is the discharge air temperature off of an air handler. Using the English language as your source of truth for what that point is would never work. So yes, it was the flow temp coming off of the air handler. I know.
Oh, okay. Yeah. I mean, I understand that, but that is a weird one. So I actually had someone, I saw a program the other day, someone asked me to take a look at it, and I was like, why do you have a building static pressure sensor controlling your supply fan? He's like, no, that's the one that's 2/3 down the longest duct run. I'm like, don't you just mean duct static pressure? He's like, well, no, it's for the building. I'm like, no, you could use a damper or a return fan to maintain the static pressure that's in the building. Like, you're just supplying static pressure. I was like, I don't like, because I looked at it, I was like, I didn't understand it at all. I sat there, I'm like, man, that's super high. I'm like, the building is like exploding right now. But like you're right. Words are really hard, but flow. That's one that I gotta put flow temp.
So I mean, those are both examples where having an ontology to sort of first map it to, however you get it there. You can get it there with people. You could get it there with trained agents. But either way, you have a target ontology that you first kind of infer, and then from there be able to do more with it. To me, that's sensible, because if you leave it completely unstructured without first trying to understand the right structure, and then from that inferred structure do more with it, you're just constantly going to be left open to inaccuracies and lack of reliability.
Now, would you prefer to see a system that's just conforming to one or conforming to multiple?
Well, one thing I will say is that AI and LLMs in particular are probably making it easier to translate between things. I mean, you can just ask it to translate, one code base to another code base. And yes, you have to review it. And yes, I think it requires knowledge and a priori knowledge and taste to determine if it did it right, or did it efficiently, or did it elegantly. That's a sort of a different set of expertise. But my point being, to translate from ontologies to ontologies is getting easier, or languages to languages is getting easier. I also think that there's sort of a fallacy that there'll be one ontology to rule them all for everything, because the reality is, there's the CMMS world and workflows, there's the real estate and leases and asset management, and there's capital planning, and there's controls and BMS. So whatever the boundaries are, there are going to be different epistemologies that have to interact with each other. And so we have to come up with ways for these things to work. And obviously, ASHRAE and 223P has gone down like this RDF shackle sparkle kind of path, and there's semantic web and that. So I think we just have to be aware of those things. Although my hope is that AI tools are reducing the complexity for the average user of what those things are doing behind the scenes.
So, we're seeing a massive shift towards, building and energy performance standards. So do you think the industry is actually ready for that level of transparency, or are we headed for like a data reckoning, if you will?
I guess my answer to that is it varies a lot by segment. I think some segments are ready for that because they have data infrastructure and they've been working on adopting tools like ours to prepare themselves for it. Other segments, I don't know, maybe multifamily is probably a really tough one, or K through 12 schools where it can be challenging just for budgetary reasons to have all the right infrastructure to do it. I think it varies a great deal by segment to support performance standards and have the data to comply with data-driven performance standards. We're in the fortunate position where we can help with that. So most of the stakeholders we work with, they're thinking about it and talking with us about helping to solve for it. I think it's probably a bigger challenge in a lot of industries where we're not very focused for them to meet those standards. That said, most of the building performance standards that I have exposure to, they're limiting themselves to certain classes and sizes of buildings. So I think for where it's limited from a regulatory standpoint, they really ought to be ready. And if they're not ready, then they're kind of behind.
That's a very that's a great point. I can't come up with a counter argument for that at all. I agree completely with what you said. Yeah, you need to be ready now, and if you aren't, the industry is moving at times at a breakneck pace. In some areas it's super slow, but a lot of them now it's continuously shifting towards that kind of analytics that you guys do. So here's one that I think is an interesting question. Where do you think the relationship between the mechanical contractor and the software provider where do you think that is going over the next 10 years? And do you think that they're going to merge, or is there going to be a friction between the two that's going to just increase?
That's an interesting one, and I don't have one answer. I have a few different answers. So I think it's reflected in the way we go to market as well. So we have partners that deliver Clockworks to their customers, and we have enterprise accounts that use Clockworks internally. And the enterprise customers tend to be larger portfolios of buildings, often more complex buildings, and they have a diversity of vendors, controls vendors, mechanical vendors, FM vendors across their portfolio. In those instances, Clockworks becomes a way for them to have visibility, to drive priorities, to have some level of oversight and accountability, but also to facilitate collaboration with good vendors. I think it will raise the bar in terms of which mechanical and control service providers do quality work and lead to the outcomes the customers want, and those that are just kind of phoning it in and not doing what they should do to deliver outcomes for the customer. So for those large enterprise accounts, it will be that dynamic where quality will reign and the customers will have greater visibility over it, and the service providers who rise to that occasion will grow their service footprint, and those that don't will shrink. The other model, when we work with service providers and through them, kind of similar in that it is an opportunity for those quality service providers to elevate their game, but do so that's less constrained by headcount. So greater visibility over their installed service base, more remote services, more condition-based services, more outcome and impact-driven approaches where they can demonstrate to the customer that through their service relationship, they're providing a healthier building with a lower energy footprint, lower operating costs, and an efficient service profile in terms of, how many people they're sending out to site and what they're doing and how efficiently and effectively they get work done. And service providers who don't do that, they're going to start slipping, because I think the traditional way of selling labor hours and just saying, hey, if we were on site for 8 hours that month and we did what was expected of us, I think that's probably going to get weaker in terms of a position of being a good service provider. I'll say commoditized. If all you're doing is thinking of it as how many labor hours am I selling my client for service, I think that's an at-risk business model.
I couldn't agree more. When I'm teaching, when I'm teaching students, for Niagara certification, the thing that I beat into them is that, making the product what you aspire it to be is going to separate you from the other, companies that are just putting it in to put it in. So for the people listening who are just entering the industry, so we call them the digital natives, if you will. So what is one skill that they should focus on that isn't found in like a traditional HVAC manual?
So I suppose, kind of feeding off your previous comments as well, this isn't a skill, but more of a mentality, which is understanding what the building owner or facilities team is actually trying to accomplish ought to come first. Like, what actually matters to them? If you're in healthcare, pharmacy compliance, OR compliance, Joint Commission is at my door. I've got a bunch of alarms from nurses and doctors in critical spaces, it's like understanding what their pain points are and how you can help with them comes first, whether you're associated with a product or a service. And I do think, and maybe I'll say this, maybe I'm dating myself, but having some time in person with people helps really build your understanding of what matters to them. So taking those opportunities to show up in person and have a conversation and ask them about a day in the life and what really makes a difference and is valuable to them, I think helps you do your job better. And kind of calling back to your previous comments, I found Clayton Christensen's work and Innovator's Dilemma, Jobs to be Done, which are all sort of buzzwords for those who know them. But if you don't know, go look it up and read those books. And the thinking about it, that's been really influential to me, and just kind of really honing in on what is it the end customer is trying to accomplish, and then contextualize your work and your skill set in that. And if you can do that and communicate to them what you're doing around that and then execute the work, then you're going to be a lot more valuable than, if you just learn how to do a task and think that you're doing a good job because you did that task well, versus understanding the context in which that task matters.
Yeah, I couldn't agree more about being in person, and that can go a long way with people. I like when I try to give advice, especially like when a controls engineer needs to talk to a mechanical engineer and they have an issue with the sequence. I'm like, well, call them. Well, I'll just send them an email. No, call them. I'm sure that, in a 10-minute conversation followed up by an email afterwards would just go ahead and do it. Because nothing infuriates me more than having someone behind a desk shoot me an email and I never get to talk to them. Like, I'll call them and then they don't pick up, and then like they shoot me a message. I'm like, can you just call me? Like we can solve this and save a lot of time by doing that. But yeah, like even showing up in person, even if a project is not going well to start, I think really, shows the character of someone and actually can put the customer at ease. Like, okay, well, you know what? They're here, they're working on it. It may not be perfect right now, but this makes me feel better than someone just, dialing in through the internet and like, oh yeah, I got it corrected here. Sometimes that face-to-face to a customer means more than anything else. And maybe even you don't have the problem fixed right away, but you know what? That interaction meant something to them, and now they're going to trust you more.
Yeah. Well, once you establish rapport, obviously you can have different ways of working that make it much more efficient. And, the more you work with somebody, then it can just be one word in an email and you both know what's going on and you can get it done really fast, really efficiently. But don't underestimate the value of showing up in person. Or I like your point about making a phone call. People often rely on, chats or emails, but particularly when you're just starting in a relationship, pick up the phone, have a conversation. Everything else gets easier from there.
Yeah, because sometimes people infer tone through text, and it may not be. Someone may think that the email was actually terse, and it really wasn't. Like you were just sitting there, and it's like, what was that? It was Key and Peele. It was on comedy. It was on Comedy Central where. Key is talking to Peele and like he's sending a text message like and
I know exactly the one you're talking about.
Yeah, you're like, oh, whatever you mean, like the guy's like, yeah, that's cool. He's like, oh, that's cool. Like, yeah, like it's one of those where
one's
really,
getting really offended and the other one is like, oh, like this is my buddy and we're just gonna meet up next week instead.
Yes. Yeah, exactly. I had a scenario and it was called it was called Doctor's Hospital. It was on Good Luck Road. So that you should just never go there if you get sick, because that's just a bad omen. And the call I got was they were actually looking for anyone that could just service the system. And the call was, hey, we were doing a fire, we were testing the fire alarms. And this unit shut down and wouldn't come back online. Oh, okay. you know what, we'll go out there and take a look. And so I get there and, they told me like, yeah, we've got a bunch of pneumatics here. I'm like, okay, so based upon the questions I asked first and what they responded with, I'm like, all right, there's a fire damper closed somewhere. So let's go and find the fire damper closed. And we're going through floor. They actually had really good mechanical drawings. And so like I'm like, this one's open. And I'm highlighting the mechanical drawings. I'm like, okay. And then like when we're getting close to the end, the guy's like, yeah, it was the damnedest thing. I was replacing the filter and then the unit shut down. Wait a minute, you were replacing the filter? I was told that you were testing the fire alarm system. He's like, well, does it matter? I was like, yes. I was like, I'm wasting my time here. And I immediately went up to the unit and he's like, why do we need to go back to the unit? I'm like, because you accidentally knocked off the pneumatic tubing. That's it. I was kind of kicking myself when I was driving home. Like the call, I mean, I was there for like 6 hours, but I think I only charged them for 3. And the reason why I did that is, after looking at it, I was like, I should have just gone my gut and gone to the unit first. And then I would have just saved time in that. But instead, I went and listened to him at first. I was like, okay, well, obviously if they're testing the fire alarm, then it's got to be the damper first. But like, had I just gone there originally, I'm like, yeah, I feel bad charging them 6 hours for something I probably would have taken less time had I gone through that. But, I think that's part of the same thing of like going ABC.
Should have charged them 9.
So, going still with the young professionals, what do you think the most underrated opportunity for young professionals is when they're entering the building space right now?
The scale of the opportunity, if you're willing to learn and then help drive change, is massive because there's just so much work to do in modernizing buildings, digitizing buildings, creating software and agents, and so on. So, you hear a lot about people kind of falling into HVAC and controls, and maybe that will remain that way. But there is just so much opportunity in our industry to make a big impact and make a difference, both in terms of technology change and technology adoption, as well as in, energy and environment and climate. It's just a diversity of ways in which you can have a meaningful career, gain really valuable skills, and make an impact in our industry that I just think a lot of young people still don't know about. So I think your question was, what's the most underrated? Is that what you said?
Yes.
Yeah. So I think the scale of the opportunity to have a good career and make a difference is perhaps the most underrated thing for young people entering our industry.
I like that answer a lot. On the building automation subreddit forum, which is a wild place if you've never been, there have actually been a lot of people now, more than ever, both young and old, that are wanting to get into the building automation industry in some capacity. You've got some that are really smart with like computer science backgrounds, and then some that just have like just a straight refrigeration background. And obviously I think the answer for both of them, kind of differs based upon their skill set. You've got some, smart HVACR, refrigeration techs that are good with a computer because they grew up, like, let's say in the age of where, they grew up without, or they started growing up without a computer, but then like maybe like in their teens, they finally got the computer, and then moving forward with that. But then you've got people that were just in the computer age, and that's the way they've always known in technology. So some of that stuff has just become easier for them, but actually becoming hands-on is where they, is where they lack. And I think that if you merge the two together and just pair them up, they can be such a workhorse. Like there's a company I used to work for called Engineered Control Solutions, but Lee Revis, who was the owner and founder of that company, he envisioned that, 30 some odd years ago, where he understood that there were people that were really good at certain things, but not everything that, the original tech had to be. And so, by doing that and pairing people together, you then created that machine that could just work really well. Like two, three people could just go into a building and knock it out, and they're all just happy and humming along and moving forward, and it just becomes very orchestrated in that. And I think that, I think that's where these young professionals, come into play, where, they definitely have more exposure to the technology now that's coming up. And some of them are faster on the quicker on the draw with that. And I think that, some of the older people need to recognize that and especially give them that opportunity to do so. Because I think in some cases, there's a lot of gatekeeping that's still happening. It's a matter of being open-minded to working with them, to help them grow. Because that's the only way that's going to work, is that if we cultivate the young professionals. And also, I think there needs to be a level of drive. As you know, that the building automation industry is at times most baptism by fire. And in that case, you really have to, you really got to be prepared. Clockworks your trajectory has just been nothing but amazing. And looking at that trajectory of Clockworks and the industry at large, if we finally get this right, like if we solve the physics and the data, in your mind, what does a perfectly operating city look like in 2040?
Wow, that is a big question. Well, I'll answer with respect to kind of the world in which I live, which is I think that data from every physical asset is being monitored and structured and analyzed and informing every aspect of decision making about the operation of that city. So the energy consumption of buildings, the carbon emissions of buildings, physical assets that need replacement or repair, maintenance that needs to be performed on any dimension of the built environment across that city. Essentially everything is connected. Now, I also think, especially with the track we're on now, there's going to be tremendously more automation in terms of, self-healing components, auto-correcting controls, supervisory control that is more global, more automated, maybe even more agentic, that the interaction between the grid and the built environment will look different. There'll be, a lot more dynamic interaction between power generation and electricity consumption. I think it's highly likely that it'll be a much more electrified, as distributed generation, diversification, and decarbonization of grids occur. So there'll have to be this dynamic interaction between the built environment. Let's see, 2040, I have to remember it's already 2026. So I don't want to get too futuristic here, but the things that I just described, I don't think they're that far away. I mean, I'm not talking about flying cars. I'm just talking about,
right.
I'm just talking about leveraging, connectivity and data and analytics and AI and agents and so on, which is already in motion today. So I'll just pause there because there's a lot more we could imagine in 14 years or 100 years.
Sure. Yeah. Like all of a sudden then you have open the bay doors, Hal. I'm sorry, Dave. I'm afraid I can't let you do that. Yeah.
Yeah.
No, I think that's, I mean, you've really brought a unique perspective to this entire conversation. And I like your vision, and you're right. I also don't think that we're that far off from that. Obviously, 14 years, probably not, like, maybe 30 years, like that could absolutely be more realistic, but obviously, we don't know what the future holds. I mean, hell, most people now are afraid of the hantavirus, and I'm like, guys, okay, look, I don't think it's something you really have to worry about, but they're one foot in front of the other. But Nick, it has been a pleasure having you on this show, and maybe what I'll do is I'll I'll connect with you on LinkedIn, and we can have some more chess conversations.
Sounds good. Yeah, it's my pleasure to be on the show, and I feel like I'm in the community of friends in this industry and among your listeners. So I'm very happy to have the conversation, and hopefully I'll get a chance to meet some new people based on your listeners. So thanks for having me on.
Oh, absolutely. You're welcome.
Thanks, Nick.
And that's all we have for this episode. Remember to stay curious and stop reacting. Start mastering your systems. Until next time, I'm Charles.
And I'm Matthew.
And this has been It's a Controls Problem.
One ontology to rule them all. One ontology to find them.
What about second ontology? Shut up, Pippin.
Yeah. 11 C's.